Plans are orthographic projections on a horizontal picture plane looking down on an object or scene. To project a plan view of a building's interior, we must first make a horizontal cut through the entire structure. After a horizontal plane slices through the construction, we remove the upper part. The floor plan is an orthographic projection of the portion that remains. The plan cut slices through a building's walls and columns about 4 feet above the floor. It's important to differentiate the cut walls and columns from the spaces they define. The easiest way to do this is to profile what is cut with a heavy line weight. Begin a floor plan by drawing the lines which regulate the positions of plan elements. Once the ordering system is established, give the plan elements their proper thickness. Emphasize the cut elements with a heavy line weight. Use intermediate line weights to delineate edges of surfaces below the plan cut, and the lightest line weights to represent surface lines. We typically give the cut material a tonal value that contrasts with the spatial field of the floor plan. We refer to this darkening as poché. If only a moderate degree of contrast is desired, use a middle gray value to illuminate the shapes of the cut elements. Poché establishes a figure-ground relationship between solid and void. We tend to read the cut elements of a floor plan as figures, and the bounded spaces as background. To focus on the shapes of the spaces, we can reverse the normal dark-light pattern. In order to emphasize the plan cut, as well as convey a greater sense of depth, we can also render the shadows cast by the vertical elements of a floor plan. An elevation is an orthographic projection of an object on a vertical picture plane. A building elevation is a similar view on a picture plane that is parallel to one of the building's principal faces. Building elevations convey external appearance, form, materials, and patterns of window and door openings compressed onto a single plane of projection. To show a building's relationship to the ground plane, building elevations should include a section cut through the ground mass at some distance in front of the building. We need a number of related elevations to fully describe the exterior appearance of a building. As we move around a building, we see a series of related elevations which change as our viewpoint changes. We relate these views to each other by unfolding the vertical picture planes on which they are projected, forming a horizontal sequence of drawings. Elevation views cannot represent the diminishing size of planes as they recede from the spectator. When we draw surfaces in elevation, we must rely on graphic cues to convey depth, curvature, or obliqueness. Begin with the lines which regulate the positions of major horizontal and vertical elements. Once the ordering system is established, draw the elements parallel to the picture plane. Then establish the elements that are curved or oblique to the picture plane. Since planes perpendicular to the picture plane appear as lines in orthographic projection, it is difficult to convey depth. Regardless of their distance in space, all lines and planes parallel to the picture plane retain their true size. In a pure line drawing, a hierarchy of line weights conveys depth. The heaviest line weight defines the ground line of the section cut in front of the building. Extend this ground line to describe the topographical nature of the setting. The next heaviest line weight profiles the planes closest to the plane of projection. Progressively lighter lines indicate increasing distance from the picture plane. Use the lightest line weight for surface lines. These simply represent the visual pattern or texture of surfaces. Tonal values can establish 3 pictorial zones in an elevation drawing: the space in front of the building, the space the building occupies, and the space beyond the building. First establish the tonal range of the building. Then establish contrasting values for the foreground and background. Darker planes may front progressively lighter planes in the distance, or vice versa. To project a building section, first make a vertical cut through the entire structure. After a vertical plane slices through the construction, remove one of the parts. The building section is an orthographic projection of the portion that remains, cast onto a picture plane parallel to the plane of the incision. This cut opens up a building's interior to reveal the vertical dimensions and arrangement of spaces. Beyond the plane of the cut, we see interior wall elevations as well as objects that occur in front of them. As with floor plans, it is important to graphically differentiate the cut material from the spaces beyond the plane of the cut. The easiest way to do this is to profile what is cut with a heavy line weight. In drawing a building section, we begin with the lines which regulate the positions of major horizontal and vertical elements. Once the ordering system is established, give the cut elements their proper thickness. Next, emphasize the shapes of cut elements with a heavy line weight. Use intermediate line weights to delineate edges of surfaces beyond the section cut, and the lightest line weights to represent lines on surfaces. To convey a stronger sense of depth, give the cut a tonal value. We refer to this darkening as poché. Remember that the ground mass is also cut in building sections. The tonal value of the section cut should continue into the supporting ground mass. A second approach is to reverse the value scheme and render the cut elements as white figures against a spatial field of darker values. Emphasize the section cut as well as convey a greater sense of depth. We can also render the shadows cast by the cut elements. Multi-view drawings are a related set of orthographic projections. Each projection reveals a particular aspect of an object, but together they are able to fully describe its three-dimensional form. Orthographic projection uses projectors perpendicular to the picture plane. This side view shows the perpendicular relationship of the projector to the picture plane. In orthographic projection, each point on the object is projected perpendicular to the picture plane. This side view shows the parallel projectors are perpendicular to the picture plane. We draw the orthographic image by connecting the projected points on the picture plane. A single multi-view drawing reveals only partial information about an object. Ambiguity of depth occurs as the third dimension is flattened onto the picture plane. A series of related views is required to fully describe the three-dimensional nature of a form. To do this, we establish another picture plane perpendicular to the first. Onto this picture plane, we construct another orthographic projection. Rotating the construction shows the perpendicular relationship of the projectors and the picture planes. This second orthographic projection gives us information about the depth of the object which the first projection was unable to describe. To provide a complete picture of the object, we establish a third picture plane perpendicular to the first two. Onto this picture plane, we construct another orthographic projection. Rotating this construction again shows the perpendicular relationship of the projectors to the picture plane. This third orthographic projection gives us information about the object which was missing from the first two projections. This pictorial view illustrates the relationship of each orthographic projection. The three picture planes which are perpendicular to each other form a transparent box around the object. To establish the proper relationship of the three orthographic projections, we unfold the picture plane box into a single plane. The result is a coherent set of orthographic views. Align related orthographic views so that points can be transferred easily from one view to the next. Project points to adjacent views using projectors that are perpendicular to the common fold line. Given two orthographic projections, we can construct a third related view. Construct a diagonal bisector at the intersection of the fold lines. Transfer points in the top view horizontally to the diagonal bisector and then vertically to the side view. Project vertical dimensions horizontally from the front view to the adjacent side view. Each orthographic projection is a distinct two-dimensional view, but when seen as a series of related views, they are able to fully describe the three-dimensional nature of a form.